560 feet long, 5 stories high, generating enough power to light 20,000 homes. This is Trident, built by Electric Boat. Electric Boat is the founding and largest division of General Dynamics. More than a third of the Navy's nuclear submarines have been built at Electric Boat Division Shipyard in Groton, Connecticut, and almost all of them have been designed here. The division's long and successful history began with the delivery of the 54-foot USS Holland, the Navy's first submarine, in 1900. During the next 50 years, improved designs followed, but the submarine was still a submersible surface craft, capable of only limited underwater runs, driven by huge storage batteries. While submerged, the submarine was in effect an electric boat. Then in 1954, Electric Boat launched the Nautilus, the world's first true submarine. With her nuclear power plant, she could cruise underwater for months at a time. The advent of the nuclear power plant, which runs silently and does not require oxygen, led to a new era of underwater design and technology, and a dependence on the submarine as one of the nation's new weapon systems. As the nation's foremost designer and builder of submarines, Electric Boat has pioneered dramatic advances that have led directly to Trident and today's fast attack submarine. These boats, as they are still called despite their size, are the latest achievements in a long tradition of building the finest. In this shipyard along the banks of the Thames River is a degree of know-how, experience, and pride seldom achieved in any industry. It is all needed to build today's submarine. The technical challenge is enormous. Trident, with its 24 long-range ballistic missiles, is the single most important defense effort in the free world today. It represents the world's most advanced technology in weapons systems, ship control, and electronics.
Outboard, clear water inboard, set your depth to 280.
On a modern submarine, each ship function is monitored 24 hours a day. This control station represents the engineering and design technology necessary to guarantee that the submarine will operate safely in its hostile environment.
Control, pressurized.
So keep us on course, and you might give me a little bit of help on the fair works getting the depth radar.
Advanced submarine motion simulation techniques accurately predict the submarine's response to her controls. Mastery of the sophisticated hydrodynamics of submarines is a hallmark of Electric Boat's engineering expertise. Underwater acoustics is another highly specialized discipline at Electric Boat. To avoid detection, the submarine must be silent. Sound travels easily in a fluid environment. Listen to the voice patterns of whales. The croaker fish as he grinds his teeth. Friendly porpoises. Now listen to the unnatural sounds produced by a submarine. To ensure quiet operation, laboratory engineers record the sound frequency of each of the ship's thousands of moving parts.
Time is 14:54, Mark 14.
There must be no variation from specified levels. The slightest sound travels for miles. The same meticulous attention to detail is devoted to all ship systems, where engineers apply the most advanced computer techniques in the industry. This is a computerized piping design system that produces three-dimensional drawings from design data. Another computer system mathematically checks the stress and flexibility of the ship's piping and structure.
Over here we have another stress concentration.
Computer-aided design details part geometry and dimensions in a fraction of the time required for manual drafting. A unique ultrasonic imaging system detects the most minute flaws in seawater piping. New techniques and computer programs to aid the engineer are constantly being explored and designed. Improvements never stop. Design and engineering are one part of the story, but it is also Electric Boat's responsibility to get the design off the drawing board and into the water. The manufacturing process begins at Electric Boat's facility in nearby Quonset Point, Rhode Island. This field of heavy steel plates is the stock that will be cut, formed, and welded into the myriad shapes and sizes needed for the assembly of the submarine. A computerized inventory system allows efficient use of the steel plates. Parts are carefully arranged, so scrap is at a minimum. The computer remembers, and the parts are cut automatically. This huge structure at Quonset Point represents a giant step forward in technology. It houses the automated hull cylinder assembly facility. This equipment is the most sophisticated of its kind in the world. It has substantially raised the industry's standard of quality. Massive jigs and fixtures achieve precise dimensional control, and advanced automated welding fixtures traverse every hull seam. The facility is turning out hull cylinders at a rate thought impossible a short time ago. The magnitude of the manufacturing and assembly task becomes evident by the size of some of these hull cylinders and the equipment needed to move them. Completed cylinders and structural assemblies leave Quonset Point by barge. At the assembly facilities in Groton, the huge cylinders will be welded into hull sections, outfitted and joined to form the massive hull of a modern submarine. The Trident construction and launching complex is the only one of its kind in the world. The facility was designed and built specifically for Trident. While the fast attack submarines still slide down the ways in conventional launching fashion, Trident is gently floated free of its land ties by flooding a huge basin.
Launch!
Launch day and the attendant traditional ceremonies always quicken the pulses of those who witness them, but none more so than the men and women responsible for this day. The team that put together this marvel of the atomic age, put it together and sent it to sea.